In this next problem, we already have the absolute value isolated by itself on the left. And there is a less than. That tells us that 3 minus 7x is going to be sandwiched in between negative 13 and positive 13. Looks pretty easy so far, but we've got that negative in front of the x, and that's what we're going to have to contend with here. We are going to subtract 3 on the left, middle, and right of this problem, leaving us with negative 16 less than negative 7x less than 10. Now we are going to divide all three parts by negative 7. And whenever you divide by a negative, you need to change the direction of your inequalities. So this leaves us with 16 over 7 is greater than x, which in turn is greater than negative 10 sevenths. We do not want to leave it in this form. The reason we don't want to leave it in this form is intervals are always written from left to right, from smallest to largest, and this could cause some confusion. So I'm just kind of rearrange the whole inequality here to use less thans. Negative 10 sevenths is less than x is less than 16 sevenths. And that is our answer as written in an inequality form. In interval notation, it would be the open interval from negative 10 sevenths to 16 sevenths. Let's work on this next one. I'm going to begin by subtracting 5 on each side. And over here on the right, I probably want to think of that instead as a minus 10 halves instead of a minus 5. This gives us 3 times the absolute value of 2x over 3 minus 4 is greater than or equal to 7 halves. Now, instead of dividing each side by 3, I'm going to think of this as multiplying by 1/3. That will cancel the 3 out on the left and make it easier to work with the fraction on the right. We now have the absolute value of 2x over 3 minus 4 is greater than or equal to 7 over 6. Now we've isolated the absolute value on the left. Now we can apply the third property and write this as two separate inequalities. 2x over 3 minus 4 is less than or equal to the negative 7 over 6, or 2x over 3 minus 4 is greater than or equal to 7 over 6. Now personally, I don't like these fractions, so I'm going to multiply through by 6 on each of these inequalities so that I don't have the fractions anymore. I chose 6 because that is the least common denominator, and by multiplying by a positive 6, I'm not changing the direction of the inequalities. Now when I multiply by 6 on the left, the 6 will cancel with the 3, leaving me 2 times 2x, which makes 4x. If you want to see that written out, I'm multiplying by 6, those cancel out, there's my 2 times the 2x. 6 times this minus 4 gives me minus 24, and that will be less than or equal to negative 7 after those 6's cancel. Or 4x minus 24 is greater than or equal to positive 7. Let's solve each of these separately now. Let's begin by adding 24 to each side of each. Probably should write it on each side. That gives us 4x less than or equal to 17, or 4x greater than or equal to 31. Let me slide this up here yet again. And we have x less than or equal to 17 fourths, or x greater than or equal to 31 fourths. In interval notation, that would be the solution set starting at negative infinity, going up to and including the 17 fourths, which we denote using the bracket, united with the next set, which begins at 31 fourths and continues on to positive infinity.